So far, we're able to send a forged request, and the forged request is being fulfilled by the target web application. It's being sent to a server that we control. But there is nothing useful to get out of this, because we can't really get this web application to simply send me information of, for example, the admin page or the users to the server. All we can do is simply get this web application to send requests to a different server. So we could use it, for example, to proxy or to hide behind this web application or this server, but that's it. That's pretty much about it. So what we're going to try to do today is show you how to exploit blind SSRF vulnerabilities. Now, the exploitation might not always be possible in the way that I'm showing you today, but I'm just showing you an example of exploiting blind SSRF vulnerabilities, just so that you know that it is possible to exploit them. It's not the end of the road when it is blind. And like we said earlier, what you could do is you could try to blindly exploit the internal services and just hope that one of them is vulnerable so that you can get a connection or get code execution on the target. Now, even though we're going to be doing this blindly, we're still going to base that on the most amount of information that we can gather. So we're still trying to make educated guesses with it. So let's go to the target and let's have a look on the response or the request that was sent to our server. So I'm in my collaborator window and I've clicked on the HTTP request that was sent. And if we click on the request to the collaborator, you can see the request that was sent to the collaborator. Now you can see the host is sent to the domain name of my collaborator, and you can also see the user agent. And if you notice, this user agent is actually the user agent of my browser. It's not the user agent of the server that we are exploiting. So we're sending a forged request to this web server, and in this forged request we are given the user agent, and we are also setting the referrer to the target server, to server 3. What's happening? The web application in here is sending the request to server 3, to what we're specifying in the referrer, and it's setting the user agent to whatever user agent we selected. So if you take a second and look at this and substitute these two values with what they're actually been replaced with, you will arrive at the conclusion you could set the referrer to the target, because the target that we specify in here is the destination that the web server will send the request to. And then whatever you type in the user agent, assuming it's an exploit, this exploit will actually be sent to the target as the user agent. So all we have to do right now is simply find exploits that can be exploited using the user agent. So this is how we narrow down the amount of exploits that we're going to try on the internal servers that are connected to the same web server in here. So we're going to go to Google and we're going to look for user agent server exploit. And obviously you want to go through these and see if anything is useful, and you want to actually try some of them, and some of them are going to fail. So it's not like the first thing that you will try will actually work. But then eventually you'll hopefully stumble upon this article. It's only the third one in the list, so it's not that far in the list. And this article, if you go through it, it's going to talk about a shell shock vulnerability that you could exploit through the user agent. Now, shell shock was a very popular vulnerability that came about, I think, in 2014, or in here it's saying 2015, I think. You could read more about it on how it works. Basically, the way it works is you have this magic string. When it's sent to the server, it bypasses the filtering that is implemented by the web server, and whatever value you put after this magic string will be executed as code. So it will be executed through the shell, and hence the name shell shock. So we can send this as a value in here in the user agent, and then we can chain that with whatever command we want to execute on the target. And if the target is vulnerable to the shell shock vulnerability, it will actually execute code on that system, and therefore we will gain remote code execution on that target. But again, we're still not sure if this is going to be executed on the target, and if we want to read the result of that command, we have no way of reading that, because again, remember, this is a blind SSRF vulnerability, so it's gonna send whatever we send in here to the target, but nothing will be sent back to us. So in order for us to actually see the result of the execution of our command, we're gonna have to find a way of executing the command on the server and have it send the result to my own web server, to the hacker web server. And to do that, we can actually use the nslookup command. The nslookup is a command that can be used to query DNS records and map the domain name to its IP address. So what we're doing, we're using nslookup to perform a DNS request to a certain domain, which is the domain of my own server. And before that, as a subdomain, I'm gonna substitute my command like so. The result of substituting the command like so will be replaced in here, and then nslookup is gonna perform the nslookup request to a subdomain that is the result of the command .myserver.com. And then if I go to my server, I'll be able to read that in my logs and see the result. So just to show you a quick example, if we do something like nslookup, and then, for example, let's say we want to run a command, and let's say uname to show the computer information and kernel information. And then we're gonna put the domain of my collaborator. So I already have it in my clipboard. So first of all, it's gonna execute uname on my own current system. And then it's gonna perform an nslookup to whatever result that this command results, followed by the subdomain. As a result, my server will still receive this request because it's a subdomain of my own server. So if I hit enter and then go back to my collaborator and click on poll now, you'll notice we have another DNS request in here, and you'll notice that the request was sent to darwin.mycollaborator URL. And sure enough, the name of my kernel is actually Darwin. So if I do uname, you'll see that the name of my kernel is Darwin. So whatever value that was in here was substituted in here before the subdomain, and all of that was sent in the nslookup command, and therefore I was able to find it in my collaborator. Now, in the next lecture, I'll show you how to use this to execute code on a vulnerable server using a blind SSRF vulnerability.